before my working with large language models and how to implement them to climate data. Before we go to the implementing and all the coding stuff, I want first to talk about what is large language models. So you can think about LLMs as just two files in your home directory. First file is a parameter file, or sometimes it's called weights file, which is the knowledge of the model. And the second file is some code, 100 lines of code or so, which is instruction how to use this weights to produce and generate text. So all the magic is happening because of these parameter files. And parameters files are just a billion numbers. Like you can think about it as an Excel table with billion numbers. And for some models, we know exactly how they were trained. For example, Meta company used chunk of the internet, like around 10 terabytes of text data, web pages, articles, some maybe code, and then they compressed it using thousands of GPUs, which was running for 12 days, and it cost $2 million for them. And as a result, you have your parameters files, like 140 gigabytes zip file. And this was like 2 years ago, and if you can think about state-of-the-art models, these numbers can easily be multiplied by a factor of 10 or even more. So now it's really expensive to produce a nice lot of parameters files, so it can cost 20 or even $100 million. And if you follow up the news, maybe Mark Zuckerberg is now building the large cluster center to train the models, and it's the size of Manhattan. And so how does it work? So you did your pre-training process and you obtain the base model. And what the base model does is just predicting the next token or words. So in a sentence like Paris is a city in, the most suitable one would be France, so choose France. And in this way, model is just dreaming in text, so it's just hallucinating, you can say. So if you ask her to write a story, it will make something up. But if you ask her about facts, it also can make something up. So it might be some nonsense or stuff like this. And for a more accurate answer, you need the next stage of training, which is called fine-tuning. The fine-tuning process, you hire some people which manually label data, and you had 100 or thousands of Q&A samples, and then using these Q&A samples, you adjust your weights, model weights. This also takes a few days, but it's way cheaper than do the whole pre-training process. Then you obtain your system model, move it to production, and gather some data and repeat the fine-tuning process again if it's needed. Another techniques how you can improve model answers accuracy is called retrieval augmented generation. But here you do not adjust weights, you just send more information to large language models. So you connect external sources to it and send it together with the user query. For this, you need another model which is called embeddics models, and embeddics models just translate text to numerical representation in the vector format. So you can imagine like you have a book in PDF format, you translate it to numerical representation, then you translate user query also using the same model to numerical representation. And by a technique called semantic search, you're looking for the most suitable pages in this book, like 5 or 10. And then as a text already, you're sending it together to LLM. Here I'm just showing one of the benchmarks called artificial analysis. It's a benchmark which tests how good models are in coding, in math, in writing. There's like hundreds of benchmarks out there. Some models are good in coding, some are better in writing. But here is a more general one, and so the high numbers, which mean better results. So I think right now, GPT-5 from OpenAI is the best model we can find. But in red boxes, I put models which is open source. So you don't need to pay to use them. And they as good as the paid version. So we now have also open source model from OpenAI, but also from Meta, from DeepSeek, from China. But then they have a problem how to run these models. Before this, we can discuss different aspects of open source and paid LLMs. So the first one is data privacy and security. So with the open source models, you have full control on the model and the code. So you don't even need to have an internet access to run it. So all the data is processed locally. With paid LLMs, you send your data for external processing on some server. And most of them are promising that you're not using your data to train their models, and it's encrypted and so good, but you never know. And if you maybe heard with some cases a few weeks ago, if you ever shared OpenAI ChatGPT chats using the link, you can actually Google it and find a bunch of chats in the Google. So if you type site /chatgpt.com share and then some words like Apple, you can find a bunch of chats where people discussing apples with ChatGPT. But then they fix it, so it's not there anymore in this way. Another aspect is customization. So I presented training process. With open source models, you have the full access to it, so you can really do the fine-tuning process by yourself and increase the accuracy. With paid LLMs, it's API driven only, so you can use techniques like RAG to improve the answers, but cannot adjust weights. And the last point here, I put costs. So yeah, with API, you need to pay for subscription or for token usage. With open source, you don't need to pay, but then if you want to use models like this one, it really requires a lot of RAMs, and you probably won't able to run it on your local computers. So you need to pay for space in cloud or something like this. But another solution would be to use quantized models. So what is quantization? It's compression of the weights of the model from high precision formats to low precision integers. It shrinks the size of the model like up to 75, 90% and boosting the speed, and it makes it deployment feasible on consumer CPUs and GPUs. But then if you ask, do I lose something when I use quantized models or full 100 billion parameters models? Then you can think about it as the high precision formats model can distinguish like 50 shadows of grays, and then your quantized models can distinguish only black and white. It doesn't mean that model is bad, it's just less detailed. Here are some practical quantized models that can be used on your local computers. The one I was using in the tutorial was GM3 from Google, and there is even new version with 200 million parameters, so it can be launched on your smartphone. And if you're interested in where you can find open source large language models, you can go to Olama website. There is it can be downloaded for Mac, for Windows, and then here is just easily like 3 lines of code how to download the model on your computer. Different model parameters, and also there is embedding models if you want to make a RAG from it. Now I want to discuss how to actually implement large language models in your Python framework. So one of the most popular tools out there is called LangChain. Is a Python framework for composing large language models calls into modular chains, autonomous agents. And you might ask, why do I even need LangChain? Can I just send my data to ChatGPT and ask it to analyze it? And yes, you can do this, but if you want to use different components, like different models, different techniques, how to upload your data, tools like LangChain can easily help you with change one to another. So what LangChain provides is it provides components. So different document loaders, usage, how to use different models like from OpenAI, from open source or cloud, whatever you want to use. Then it provides the techniques how to combine these pieces together. And going even further, you can build agents which can use different tools. And we will talk about tools and agents in a second. Some other tools from LangChain company is LangGraph. It's mostly used to work with agents. So if you have multiple agents, it helps you to represent these chains and tools as graph format. So you have nodes as agents and edges as a condition of when to use which agent. And another tool is mostly for debugging. It's called Langsmith, which allows you to trace your prompted call. And you can easily understand what's going on under the hood when you call your agent. Now, if you think, so we can think that model generate text data, but it can even do something more. So it can generate structured output of your text. And most of the models were fine-tuned to use on JSON format, so it can reproduce JSON schema. And in this way, it's like a language that both sides can understand. So you can think about it as you need to write an email for your boss that you're sick and not coming today, and you can ask your LLM to do this. And what LLM will do is provide you JSON output, the tool name which I need to use. Okay, I need to send an email tool, and the arguments will be the email address and then the email itself. And then it can run some function, send this output to some function, which actually will send an email. And going even further, if you have not one tool, but several tools, you can combine them in an agent. An agent can orchestrate tools based on the user task. So it can send an email, but then it can send an alarm and do stuff like this. And it's really helpful for data analysis and optimization of some processes. One of the powerful tools is called Python repo tool. So there is some pre-built tools in LangChain and some tools that you can build by yourself. And Python repo tool allows large language models to call Python interpreter and run the code. So if you ask, okay, I need to do some math, the output from LLM would be tool name, I need to call Python repo, and then it provides a Python code, and then it sends this to Python interpreter, and you see the output of the code. Yeah, I think we can maybe skip the part with the. I was showing some examples what we did in our section in Arvid Wegener Institute. So we're probably going to build something interesting by ourselves in the tutorial. And here are some links that I find really useful. First one is Andrei Karpathy. It's a guy from OpenAI and Tesla, I think, and he has a really nice YouTube channel explaining foundational LLM concepts. So if you want to build your own large language model, so it's like 4 hours video about it. But if you want to know just maybe more about general concepts, it's also helpful. All right. Yeah, and now the second link is this GitHub repo where we play around with LLMs in our section and build some nice tools. And yeah, before we go to actual tutorial, if you have any questions so far, might be the time to ask. Too early for us, so we go to tutorial now. So I send a link to if you want to follow up. Following up, you might want to have a Hugging Face account.
Boris, you want to say a few words what Hugging Face is?
Yeah, so Hugging Face is a community-driven platform where people can exchange different models. So if you want to fine-tune a model and share it with people, it's a place where you can do it. But also it provides some space to upload your application with large language models. And so some models actually already hosted somewhere and they use as providers, so we can use free version of the models for testing. And that's what we're going to do today.
Can you pause for a moment? And so you shared the link
Yeah.
up there. So once we're in, then we'll be able to get to your stuff.
Yeah. So if you open tutorial, LLM tutorial, and open the LLM climate science Jupyter notebook. So first, yeah, if you have an account, you need to get access token. So if you go to settings and click, I can share it here, I guess. If we go to, just here, I guess. On the right corner on your profile and go to access tokens. Yeah, you need to confirm your identity and then okay, you can click here, create new token. Token type, I think for now we can just select read, it will be fine. And then token name, whatever you want, like LLM tutorial, OceanHackWeek. Yeah, go to the token somewhere. So is that people having trouble with getting access token or?
Okay, you said it's under settings.
Yeah, so if you go to upper corner in that access tokens, you'll have it.
Here. Access token. And then access token generated. Code combination.
Now, a good way to work with tokens is create a .env file in your working directory. So it's not shared anywhere here. But then if you push your GitHub repo, don't forget to set up git ignore so you're not sharing your tokens. And yeah, I guess for this one, it would be harmless because it's a free token, but there's a lot of cases when people are sharing OpenAI tokens and you can easily find something on GitHub. So, okay, I think I can get started for people still setting up the Hugging Face account.
Do we need to fill in all the details for the access token or just the name, token name?
I think token name would be.
There's an option read,
Yeah, you need
Okay.
select the read option.
Yeah, if you wanna also to trace what is going on under the hood, you can use Langsmith, but it's not really necessary, I guess, for now. So you created a .env file.
Oh, what file?
Yeah, so
I made my token.
okay, nice. The next step would be is to go on Jupyter Hub on a directory where you have your tutorial, and you might want to create a text file and footer.
Or do we need to run get puller again?
I think I didn't change much since yesterday.
Should we be, there's been a tutorial, we could different.
Tutorial are we in? Climate.
Sorry?
Should we be copying the tutorial into a different folder or? Yeah, work.
I think it's fine if you can stay there. So you create a .env file where you put Hugging Face token and you put your actual token here in a,
But we need the OceanHackWeek image, right?
yeah, it's a good point. So if you want to follow up tutorial, please use OceanHack image.
Boris.
Yeah.
Hubby, where do you find the setting to access token?
Yeah, so when you create an account, you have a type here and you have access token here.
Oh, okay. Yeah, thank you.
Yeah.
Become that one. We should keep it over.
Yeah, if you don't want to like, it's not really necessary to create .env right now for this case, but it's just a good practice. You might want to just create a parameter, a variable HF token, and then put your token.
Should we do the Langsmith bit?
I think it's fine for now. Yeah, it's optional. It's just...
So if we don't have the LangChain key, should we only have in our .env file the top line?
Yeah, only the top line here. Don't forget of the apostrophes.
Apostrophes are on the token.
Yeah.
Text file.
So yeah, I think started. So here first I import some libraries from LangChain. Chroma library allows users to, so if you create rock, you need to create a vector storage, and this is a lib package that you want to use. Some chat from template to create the templates, document for document uploader, real PDFs and stuff like this, and chain is just to chain everything together.
Boris, can you make slightly bigger?
Sure. Good enough?
Yeah, one other comment, you can't see the .env there because he doesn't have view show hidden files, but if you want to be able to see your hidden files, if you go under the view tab and
Okay.
do view show hidden files, you'll see it. Down there you can see it.
How do you create the .env file?
You can just create a text file, and then if you rename it, just dot. Anyway.
Yeah.
So here I have some code to which parsing null glossaries, and you don't need to do this right now. So you should have null glossary file here. But what I'm doing is just I'm downloading information from from this website, you have an example of how the RAG works. All right, so here we're going to use models from OpenAI, one of the open source. And as I said, they are hosted already using Fireworks providers, so they hosted, and you can use it like up. It says that you can use up to 10 cents of tokens, but if you, I can show you how much I use already, and it's not even close to 10 cents. So it's like I spent like 5 cents, but I bought 100 times already this model, so it should be fine for the week. So what I'm doing here, so yeah, I set it up my token. I initialize the LLM. So I provide the base URL, so you can find this information in the page of the model. And then I create a prompt template. So I say in the system, okay, you just an AI system, and then I set it up the human questions. And I create a chain, so I combine my prompt and LLM together. And here's the output parser. It's just to, so the things looks nicer here. And you can invoke your model, send a request to the model by .invoke. And my first question would be, okay, hello there. Yeah, hello, how can I help you?
Can I pause you? For a
Yeah.
second? So for what was happening here is when they did that chain no context invoke, so that was calling the LLM and it was sending the you are an AI assistant. Hello there.
Yeah,
Oh, are you?
exactly. And yeah, so if you open a longsmith, so I already prepared it, you can see how it was done. So is it? No. Interesting. Let me check my other. Oh. Mhm. Okay, now I'm creating another IP key for a longsmith. So I thought I already put it here, but and then I need to restart load.nv, so it's up there. And now we should be able to see. Now that we can. All right, maybe there is more steps involved to set up the longsmith that I thought. Okay. We don't need to go there right now. Necessary. Anyway, so the first step here, I'm explaining how to create RAG. And for RAG, so I have prepared no glossary file where just a description of different terms, like what is ablation, and so it's like a dictionary. And then I upload this document into the LangChain readable format. So I use document here, and then, okay, I got here some documents, so we're using like just a test version. We don't need to upload the whole file because it might not even work for this case. But if you will work on your local computer or you download the model, it should be fine. So now I'm setting up the embedding model. So I'm importing the library called Hugging Face Endpoint Embeddings, and here I use Free model. It's just a model which translates your text to numerical representation. And then I need to embed all this document into vector format. And I can do this by just using Chroma package. And I just setting up my documents and my embedding model. And the next step is I'm creating a new chat prompt template. So I'm saying that, okay, you're an AI assistant that answer user question by using the provided documents. I saved my vector store as a retriever. It's just an additional step so we can tell which retriever to use. And I combine it, I create a new chain. So I have LLM, I use the same LLM, I provide a retriever, so my dictionary and a new prompt. And yeah, it might take a while because it converts all the text to the numerical format, but shouldn't be that long. Maybe wait a few seconds here. Yeah, it's done. It just gives an initial instruction for model what to do. So you can like explain add more features if you want. So here I'm just saying that it's not really necessary for cases like this one because it's already AI assistant. But here I'm saying that please use Nova as a glossary that I provided to you.
I have a question for
Yeah.
this code up here. So you say length chain there, the documented embeddings.
Yeah.
Task feature extraction. How do you know what the task is? That like there are different like options you can select there for task, or are you just giving it a name?
Oh, this one. Yeah, I think it's just a specific for these cases because you use model from Hugging Face embeddings, and I'm not sure that how necessary it is here. But if I have also an example to use it on the local LLM, and here I don't think I do stuff like this. So I just call my embedding model from local directory. So I don't think it's really. Let's do something here. Cool. So now if I ask a question, for example, what is this stratus? Using the documents, I'm getting an answer. Okay, stratus is a type of log cloud. And so what happened here is the model first found the most suitable pages or items in our JSON file. And if we go to .s, somewhere here we have the stratus and some more documents, and then it's answering the question based on these documents. And you can compare it with the null context chain that we created first. And you see, at first it's taking longer because it's need to dream in text, but you see it provide you a bunch of different options. Okay, what is Stratus is a cloud computing platform. Again, it's an independent startup, and now this is HPE. So yeah, we didn't want that. We probably, when you ask Stratus, you might want to be interested in Meteor Road or something like this. But yeah, here in this case, if you adjust your prompt, what is Stratus in meteorology, you probably get the right answer, because information that I use here for RAG is already on the website, so probably model were trained based on this data at some point. But in case if you have some private data or data that's not on the internet, it might be really helpful. Now, let's see how the tools and agent can work. So I have an idea for my small project. I want to build an R5 LLM agent. So what I want to LLM do is download the data and then analyze it using Python repo tool. So I need two tools and I need to combine them, wrap up as the agent to them. So first, what we need to do is we need to import again some libraries. So tool for tool buildings, and then Python reference already some pre-built tools, and then some packages like Xarray and Array Lake for using the actual packages to analyze the data. First, I'm setting up my function to extract R5 data. So this is a hard-coded part, so you need to create a real tool for the LLM to use. And so it's just a function which goes to Earth Mover Array Lake and then select the region if it's needed and timestamps, and then saves this as a netcdf file. Then I need to somehow tell my LLM model how to use this function, so which argument it needs to fill. And for this, I create a R5 params class base model. So we're setting up description of every variable that can be used in this specific data set. So I describe what does it mean, what does BLH mean, what is SST and stuff like this. Then I describe how to select time steps and how to select my boundary. And I'm wrapping up as a structure tool from function. So I'm saying, okay, use this function. This is the R5 data extractor, and I provide description for this tool. So when does LLM need to use this tool? So use this tool to download the data. Then I setting up my Python repo tool. So it's a pre-built tool. I just provide some description which function, which packages to use. So I'm saying, okay, use CMOcean for color maps and use Cartopy for plugins. And I'm just explicitly telling, okay, yes, use POT show so to display the output or print so I can see everything what's going on.
Great. Can I ask a question about
Sure.
that? It says, do not mock the data. What are you telling it?
Yeah, so sometimes when it cannot find the data, LLM might be just create some numbers.
Okay.
And you might end up in that. But it's if you want to trace if it's everything was done in a good way, you might use longsmith to
see what-
trace it,
okay.
to see which tool it called.
Okay.
So it doesn't just
Sorry?
put in a like cartoon of wind speeds that it
Yeah.
that it was trained on somewhere else. Somebody.
No, it's not even like this. Just to use NP random.
No. Well, it's not far.
Yeah, and then so I setting up creating my agents using like LangChain agent wrapper. So I can provide user template. So filling you're an expert in R5 data analysis. You have these tools, and here I'm using different models, more larger ones. So, but I think it should also work with the model that we use for RAG. And So we finally can define our agent. So we tell them which LLM to use, which tools to use that we created earlier, and from the system prompt. And we invoke it again as a chain preview. So my question is, plot me SST around Antarctic until 30 degrees latitude for specific date. And all right, let's see what is going on here. So model said, okay, I need to invoke Arrow5 data tool, and there's a specific argument. So it selects SST, time range that we ask, and the boundary that we ask. Then it downloads the data, so you see which data it downloaded. So it's our data set. And now I perform Python REPL tool. So, and you can see the code that it used. So importing Xarray library, then matplotlib, cartopy, and cmotion. And yeah, it do some code. So it's opens the file that we downloaded with Arrow5 tool. And we got an error. Something went wrong this time. We can, I think, just ask maybe something different again. I just wanted to show that it knows what is ocean temperature. Maybe it's okay. So you see, when I ask ocean temperature, it's again you choose SST, so it knows what is temperature is, which variable to use. Again, creating a plot. Again, got an error. Yeah, live demo never works, I guess. But we hope to. Is it finished? Oh, it's still trying something to do. Oh, here we go.
Sweet.
Hey,
After some interaction, we got up there.
How do you get Matplotlib to make a polar plot like that? That's awesome.
Yeah, I asked to use Cartopy.
Cartopy just figured it out.
Yeah, so I think it was trained on some coding, so it's.
Sweet.
And yeah, it's just a simple setup. So I didn't provide any instruction how to use plotting tools, but another idea would be to use examples. So we can write different examples how to plot this feature, how to plot this, and then as a rack you can connect it to LLM. So it will check the example first, the most suitable cases, and then do own coding based on these examples.
What are the first two dead ones?
Sorry?
Why were the first two didn't plots? What was different about the first two plotted?
Let's see. So it's trying this type error dimension of C should be one smaller than.
Oh, so it tried and then.
Yeah, and it's
That's
yeah.
cool.
You can set the maximum iteration, so it might stack for some time and spend all your tokens, but usually I think it's like 10 iterations before it's give up.
So that it's literally learning how to do it.
Yeah, so it got an error. It's like a human, like you see that you have an
Yeah,
error
yeah.
and you're trying to fix it.
We're actually looking for funky looking plots for the visualization tutorial later. So if you have any that have gone rather awry, let's make a thread in Slack. And then we can blame the plots for that visualization.
Or you maybe we could ask them to make that. Create me a plot that has bad color bar.
Yeah, and the the steps for this bot would be, for example, so it's now doesn't have a memory. So if you ask something else, like it suggests the color bar, it doesn't know what I did in the previous step. So you can add memory to the board. You can add more tools and make it a real nice.
And if you change that to say salinity
Yeah.
and run it again, does it have the same number of bad guesses?
Let's try.
Oh.
Oh, you see, yeah,
there's-
it
Yeah,
doesn't have salinity.
well, to try,
Oh, there's a
surface pressure, some other,
Yeah,
like you do that.
Uh,
I missed something.
we can ask to build the plot in magnitude. Yeah, it should understand our. Yes. So at first it's downloading U10. Hopefully it will
Fix your
download.
typo, you know.
Yeah, and you see, so it knows that it needs to have two variables to calculate the magnitude. So it downloads the U component, then it's called V component. Then it's trying to make a plot. And here you go.
And so no bad tries in the plotting.
Yeah, this one was a successful one. So it computes the wind speed magnitude using the NFX word.
Well, I have a question. When I tried to run it, it said something about, an array lake token.
Oh, yeah, I think you need to log in. So if you open a terminal, and I think you need to run, yeah, this array lake out login in browser.
And. Okay, so I don't need like. Anything special.
No, I think so. I think this all should be set up to use array lake.
Okay, no, what, oh, no. Off, not auto. On. Okay, great. Okay, copy and paste that into my browser. Sure that matches, okay. Waiting for login. Oh, wait.
You wanna-
Was there something that had to be done?
Yeah.
Oh, wait, I have to sign up.
I think you will should have an account, right, Alex? For
Yeah.
array lake.
If anyone doesn't have access, I try to use whatever email folks had when I signed up or organized that for that.
Okay. Let's see here. Continue.
And some stuff that so
What's
this
the code? No. Go. Welcome through.
so
Did you write up what the setup was like for Array Lake on the,
Yeah, so I just, in the same gist that I have notes on.
Oh, okay.
It's also in there,
okay,
along with some care.
right.
and here I presented how to use models from Hugging Face, but if you want to use it after OceanHackWeek, you might want to download the models on your local computer. And I have a additional part here explaining how to do this. So if you use Alama that I showed you previously, you can easily find on the website a bunch of models and then just Alama run Gemma free or whatever model you need, and it will download it on your computer. And then with LangChain, you can call it using Olama LLM just and to find which model you have on your computer.
And that'll run on a laptop.
Yeah, on your
without
laptop,
Sound enough using for PC.
exactly. So you might don't even need internet, so you can
Were you able to?
but then you need to be careful. How much RAM do your laptop have?
Yeah.
It's-
Right, something. This piece.
Where's there was fun square crashing.
Yeah.
Burned it up, heat up your house.
Or
Oh, this is my son's computer.
commissioner.
Boris, going back to your presentation, so you had the fine tuning versus
This one?
so fine tuning versus pre-training, those are two stages that happen in chronologically, or you can go into fine tuning without pre-training.
No, well, fine tuning is happening when you have your base model.
Base-
Yeah, so you need to obtain the base model first, then you fine tune. And fine tuning can be repeated several times, so you can adjust and adjust and adjust it.
But once you have a base model where there's essentially fine tuning, is just
You're just adjusting weight, so adjusting this giant Excel table.
He wants to.
And in Hugging Face, you can find a bunch of different fine tuning models. So people do fine tuning for their own purposes. So
when somebody does their fine tuning,
yeah,
you can just continue to fine tune it and then re-upload back.
yeah. So this is a way to share different models.
And do those models? Is it just weights? Or is there code in there? Like when you use one of these things. Are you also installing their code on your machine, or is it just the model?
Yeah, I think so here is also files. Yeah, it's more than 2 files, I guess, but it's just a description for everything here. But when you install, yeah, you need to use their code as well, because they describe like actual neural network interactions between the weights of the model.
So it could be a vector for virus.
Well, I don't, I mean, it's like on a GitHub when you're using code
Yeah,
from GitHub.
Sure.
And I think
but
when
buyer
you,
beware, you probably should be a little careful what you install.
yeah, of course. I mean, if you're using models just from NVIDIA, probably there is nothing to worry about. But when you go to some really private one, maybe it's yeah, better to check first.
Yeah, the PH root.
Yeah.
It's let me just, yeah, sorry. I'm a system administrator. I immediately feel like, oh wow, it's gonna get hacked.
No, and I think it's a good practice to be aware of what you're downloading on your computer in general. So did people manage to get the picture?
I did, I had to create the directory temp,
Right,
because it was saying,
Yeah.
no permission.
yeah, good. Yeah, sorry, you need to, if you want to follow up tutorial until the end, you need to create a TMP directory. Because it's
Noted.
my function for error file downloader saves the files into the folder, and I think I didn't create it at the beginning.
Let's go back up. No.
And yeah, we're actually having one project who building the different types of agents here, so really excited to see what we will get in the end.
Oh, maybe we can use the. That you just. Yeah. You should ask.
So for creating that, like rag, like higher up,
Mhm.
like all the, extract, okay, so like this part where you're like the ERIA5 params. defining this
Oh.
pandemic schema. So can you talk a little bit about like, hey, if you are going to a new data set, and you're starting to like pencil out what are the things that you need to know about that data set, how you enter that?
Yeah, so I think there is no universal way to go. So this pydantic schema is to model and understand how to which argument to put in your function that you pre-described earlier. And so I suspect that if you want to work with a specific data set, you would need to check which variable it contains. So you won't end up in a. So here I pre-described every variable in a way, and if I wouldn't do, if I didn't do this, and I ask for salinity, for example, and I see there is no salinity here, the model would ask for salinity, it will make something up, and it will be an error. So in this case, I strictly show which variable to use, and so and only use these variables.
So what would happen if you put, like in your question, say plot salinity?
Now it would just yeah.
I tried that and it actually tells you, sorry, I can't do that.
Yeah,
But you put in, you misspelled wind and it figured it out, right?
yeah, because yeah, it understands like what is wind, what is
But wind is in the label of.
yeah, but I
Yeah,
have
but
been
he didn't put in wind, he put in WINT.
yeah,
Close.
because so if you ask ChatGPT, for example, something, it also probably will understand that you just spelling problem.
Ah,
error,
okay, okay. And so when you asked it for salinity, do not include, okay. Okay, the variable.
and it provides you like different examples what it has. So
What if you said, plot how hot the water is? You know, it doesn't know, can it figure out like
About the heat content.
the water is
See if it actually
around,
does a calculation.
yeah, around Antarctica until. Yeah, there, just like that, picking it.
so it's selecting SSD again.
Ah, it's okay, so it did, it was
Oh.
like, okay, I've got,
Uh,
but it figured out that that should be temperature.
yeah, but I think because maybe I already have this file,
Okay,
so I can just clear my directory here.
Does it keep any memory between individual runs?
In this case, no, but it can be set, so the memory can be set up. It just involves a little bit more coding.
Okay, because I
Preparation.
was wondering if it already knows.
No, essentially not. And it's always, if you want to have memory, it means that you need to spend more token on
Yeah,
this,
yeah.
so
Stores.
yeah. So you, oh, okay. Yeah, sometimes it does weird stuff.
This is a bad plot.
okay.
Did you tell it to, like, when you got the permission error, did you just tell it that if the file already exists, just Excel?
No, I think the problem was, so yeah, I think it might work, but I need to make more explanation in the Python REPL tool. So like, please check which files do you have already, and if there is suitable one. It's actually, it would be interesting to check.
REPL, I don't know what REPL is.
I don't remember what it stands for, but
Read, evaluate, print.
yeah,
Okay,
It's the like process and internal.
yeah,
Yeah.
okay. I've seen it around.
Yeah.
That's easy. Can you ask it to plot average winter time storming or temperature?
Sorry, what again?
Like, see if it can calculate
Mean,
a mean like,
Yeah.
for a time period.
let's try. What mean SST for,
January.
yeah, for yeah, this might actually, we'll see how it works, but so it unloads the data and we crashed because,
Yeah,
yeah,
it's too big.
yeah, it's too big, I guess.
Yeah. Oh, that's cool. At least it tried. I mean, it got the parameters, right?
Yeah, it got the parameters, so it's like the time start from January 1st to January 31st.
Yeah. Yeah. Super cool.
And yeah, so when it runs the code, it uses your computer for this. So you might be ended up with limited RAM. And it's also quite dangerous tool because it might do some stuff that you don't want to have. Like, I don't think that it will delete your system folder or something like this, but
Presumably, it would ask permission,
yeah,
or your OS would ask permission.
all right. I think, yeah, this is so far.
Really cool work.
Cool.
Yeah, if people have more questions, I'll be happy to answer later on. Just reach me out somewhere. And this might be a cool, yeah, project idea for maybe if you want to explore more and if you have a nice idea which tools it might have. It's not necessarily can be something in geoscience, but for you can build your agent for sending emails for your boss or something like this.
So so you've created this and we can run this in a notebook. When you like want to, let's say, create a dashboard, like something public. Or yeah, something like that. What would you kind of integrate this into? What's the next step look like? Are there like standard ways that people would do that?
Yeah, I think most of the dashboards they're using API models, but like using API code from OpenAI or something like this. And then I think like you need to like Docker or something to do all the Python codings.
Okay. And then like, where do you host it? So
yeah, so Hugging Face allows you to host actually some stuff. And last year, I remember we did like a small OceanHackWeek chatbot, and I hosted there, but I think I used models from this was hosted somewhere else, and the platform is closed now, so it won't work functionally. But yeah, it's restarting the process. But yeah, Hugging Face for free, it allows you to have some CPUs and small RAM. And if you want to have more, yeah, you have to pay like for GPU or stuff like this.
okay.
It's a lot,
Okay.
but probably it will fail. Yeah. You must provide an analysis. Okay. So I was using here models from Helmholtz Center in Germany, and I think my API key is that already. And it was like part of the project where we have the data sets. So I tried to make a chatbot which used RAG based on the README files from all the projects that we had in OceanHackWeek. So you can ask what was the project in 2022 or which data set they use and stuff like this. but we can see different spaces, like, so people do post a lot of things here. Yeah, I don't know what this one does. I think it's changing images to something else. So yeah, you can explore spaces in Hugging Face. There is a bunch of different examples what people did with LLMs, just small chats or maybe something, rocks and stuff like this, and maybe give you an idea what can be done for your purposes.